Called Microsoft Strikes Again.
Yeah. Hi, Ron.
Bully, hi, are we on?
Yep.
I think we're ready to welcome the Stargazers once again, ladies and gentlemen, on a cloudy day, unfortunately, to our 168th program, our episode 168 of Astro Hour. That's Santa Barbara Astro Hour for you and yours. It's a little weekly vlog podcast for Santa Barbara, California's longtime astrophysics club, the Santa Barbara Astronomical Unit. I'm Ron Heron, your host. We're going to meet the gang in a moment here. I call them the Brain Trust. We do meet, though, a couple times up at Santa Barbara's beautiful Natural History Museum every month, usually for our meeting, first Friday. We also do a lot of outreach, and boy, I tell you, this is a busy week, everybody. A lot of stuff going on. Our outreach guy will go into details. I think we got Telescope Tuesday tomorrow night out at Camino Real. We're going to be at Montessori School on Thursday, Westmont on Friday. Back out at Camino Real for International Astronomy Day on Saturday upcoming. Before I introduce you to the gang, let me tell you the headlines. We're going to try to talk about these particular topics this week. There's a nearby brown dwarf out there, nearby meaning probably scores of light years away, but nevertheless, these things exist in kind of a netherworld. This one does, between planets and stars, and it may have a moon around it. Speaking of moons, that's going to be the subject of our June 14th talk featuring our museum's astro programs manager, John Winkowski. Different moons of the solar system. We're going to visit some craters and one valley at least on the surface of our moon. What if we could send a camera into a black hole? A computer is going to do it, or has done it. Oh my God. And we got a Big Bang poem we're going to share with you at some point, along with an incredible video. This would be NASA's TESS orbiting telescope catching a star being eaten alive by a black hole. Whoa. And from zodiac light to northern lights that much of America, much of this country we live in is seeing these days. Florida got to see it, I guess, but we don't for some reason.
Oh, people have seen it here.
Have you?
Yeah.
Not with our lighting. Let me introduce you to the gang here before we do our sillies. And here is our president, Jerry Wilson, 7 years and counting.
Hello.
Married to a lovely lady by the name of Pat Forgy. Chuck McPartland is back and healthy in front of the Ukraine flag. He's married to another Pat McPartland, who's our merchandise manager and our new treasurer. We have Bruce Murdoch on board, longtime supporter and telescope enthusiast, knows his stuff. We might be reading an email from him that he sent us. He's also president of the local Santa Barbara Theater Organ Society. Here's our newsletter editor, former Westmont College professor Tom Whittemore, married to Maureen. Bruce's wife is Bonnie. And right. I think Tim Crawford is with us. Yeah, hello, Tim.
Howdy.
And telescope expert. You still do Telescope Tuesday, or no? Tomorrow night is the workshop, or has it been canceled?
Well, we canceled it for just tomorrow night because we're going to be helping out at the Camino Real marketplace.
Okay.
Provided the weather cooperates.
Yeah.
Before we go to the silly cartoons, anything you want to add, Mr. Outreach, Chuck?
No, just that, with the marine layer coming in, even though some of the weather prediction sites may say it's clear, if you're going to come out for outreach, look up, and if you can't see any stars, we can't see any stars.
And we have
that more often than not.
Yeah.
Got a name for every month, right? May gray, June gloom. What's July?
No sky.
July, no sky.
August.
August.
So this
Your
is
fear.
August or foggiest, either one.
Well, it could be worse. We could be in southern Canada where it's burning alive. Maybe you've been hearing that story. Okay, let's go to the sillies. And these are science cartoons. I like this. There's been an accident. Call the first responders. Look what happened. Increase that size. There's been an accident down
together.
It's the Crazy Glue Factory, and these guys are stuck together. I'll tell you, what a bonded group they are. That's where they take the horses, right? After they die, make glue, or do they still do?
No, that's a different kind of glue.
Different glue. It's not crazy glue.
No,
that's hide glue.
Boy, there's some incredible. I just bought something that it will keep you from having to sew pants anymore. It's called No Sew. All right, this one's going to need some explanation. A couple of big rigs collided, one carrying Mentos and the other Coca-Cola. Don't think you realize how close we came to a world-ending event. You want to explain that, somebody?
Well, if you've ever taken a Mento and dropped it into a can of Coke or a bottle of Coke, the reaction is violent.
Okay, the same thing happens with any of the sweeteners. I showed that to my granddaughter once. I opened
Oh,
a
is it?
2-liter.
I didn't know that.
Yeah, you put Splenda or Sweet
Yeah.
and Low, and boy, it just becomes a gushing. Okay,
Yeah.
and that's
It's
a
the
real
Coke.
picture too. All right, here's the Coven of Witches. Oh my God. We blow that up a little bit and we'll see in black and white a problem that was averted years ago when the witches coven finally realized, one of them telling the rest, it's called a lab coat, girls. Our study found that wearing one has decreased the chances of being drowned or burned alive by a mob of angry villagers by about 95%. They're also called butcher smocks, but that's all right. Here is one of our astronauts meeting an alien on the moon or somewhere out there, and he says, you know what? We do like hospitality, but I'd invite you back to our planet. But, it's a stinking mess. I'm sorry. Like my apartment. Yep. And here they are. What did I write down about this one? This is the Three Peanuts character. Is that Linus on the left?
Yep.
Okay.
Yep.
And Charlie Brown is there in their musing with Lucy,
And
right
Lucy in the middle.
And we've thought about this, but the people that paint the pictures of Adam and Eve, they don't know. She says, what's really funny, guys? Paintings of Adam and Eve where they both have belly buttons. Think about that. Take as much time as you need. Was there an umbilical cord in their creation?
It depends on which version you believe.
These are great. Okay, on the moon again. It's a playground set up for astronauts, and the guy's stuck at the top, and the ones behind him go, "Oh, what are you waiting for?" And he says, "Gravity."
That's a great one.
It really is. Okay, here's one that requires something rather interesting. You reach a point in life. Most people take the left turn, which is the simple but wrong as far as answers. And like
Goes off a cliff.
lemmings are going right off a cliff. If they take the right turn, it's a long, curvy road up the hill, but that's where the complex right answers are. That's pretty good, isn't it? And there's books in a bookcase there next to the right side answer.
You have to do your own research, yes.
Yeah. We could have saved all these over the years and we'd have an incredible compilation of silly science cartoons, but it would certainly clog my email box. Okay, what are we going to talk about, gents? Let's go into the night sky and say hi to some folks that may be listening out in the Midwest. Old friend of mine. Okay, here we go. This night sky. Okay, this is our planets.
Okay.
Where are they?
So this is a photo or a diagram from the BBC. Apparently in England, they have a astronomy magazine that they put out, and this is an illustration from that. For the month of May, these are all on the Ides of May 15th, except the Mercury over there shows May 1 to May 31st. And it shows the relative size in your telescope. You can see the scale, the legend down on the right. It goes from 0 to 60 arc seconds. So that's 1 arc minute from 0 to 60. And you can see that Jupiter is typically around 50 arc minutes across. It's usually the biggest thing, it's in the sky. So this shows the phase you see and the relative size. Mercury is progressing from a crescent to a gibbous phase, passing through one of its half quarters. So it is coming toward, it's near us and it's moving away to get smaller and gibbous. Venus is near full phase. It's probably a gibbous phase. Of course, Mars, Jupiter, Saturn, Uranus, and Neptune, they're all full, as they always are. I don't think from Earth we'd never see them as a crescent. But if you look, this is what you will see. The situation, though, is more dire, especially for here in Santa Barbara, where you can erase this chart and just think of it as May gray. You'll see the bottom end of the marine layer. But Saturn, many of these things are too close to the sun to observe. Saturn, Mercury, Venus, Mars is a little farther away. Jupiter reaches superior conjunction with the sun on May 18. So not much going on. The other chart would be if the sun didn't exist. So
for the phases.
Yeah, these are from the BBC Sky at Night magazine.
How many arc minutes are in a degree?
60.
Just 60. Like seconds, minutes, and hours. It's just like time.
And then there's arc seconds inside of the arc minutes, 60 of those too, right?
Right.
Yeah. One down here is, well, this is arc seconds. So this is 1 arc minute. Then there's 60 of these in a degree.
And 30 arc seconds is about the size of the moon.
Right. 30 arc minutes is about the size of the moon.
Oh, arc minutes. Yeah. Half a degree.
Half a degree, yeah.
Okay. Now our moon is about the only object up there now that you can see any detail on without getting blinded by the sun. And even so, it's just a few days past its new phase. So it is still a crescent. There's an interesting feature. The moon right now, tonight, I believe, is just a little more bright. The terminator's moved a little to the left here from this diagram. But this is the crater Riata, the Riata Valley, and a crater called Young D. So it's several overlapping craters that separates the larger crater Riata from Young D. And these are not things that hit the moon all at once. These are different age craters. So they just happen to land here at different ages. And you can see they go from, if you look at this a little sharper than this is, you can see that they are more worn down. It's like a history of craters in that area. This is the part of the moon where the thing up here is taken. And the crescent is about like this tonight.
Maybe a little more, because we'll have first quarter tomorrow night, pretty much.
Yeah.
Oh, really? Okay, so then it's right up here.
Yeah.
Okay.
I don't recall seeing too many valleys on a moon. What makes a valley on the moon?
A whole bunch of craters that land in line. We have some
a
nice
rolling crater, a rolling meteorite.
Okay, well, a crater's a crater, and a sea is a sea, and down here on Earth, a river makes a valley. That certainly doesn't have it on the moon.
Well, they have rills on the moon, which are like lava rivers that have gone and made channels.
and collapsed. Yeah.
There's also the Alpine Valley, which is where a big chunk of debris just blasted through a mountain range, essentially.
Have they named some of those rills?
Oh, sure.
Oh, okay. Well, I don't recall us having many of those on the screen.
But we have had some in the past. I'll make a point of it for next week.
Okay.
This is the very interesting crater Petavius. It's a circular crater with a mountaintop, and it's got a characteristic fault going from the center mountain out to the edge. So it's unique in that sense. It's its spotting feature. Here's a crater that is apparently these kind of things are made by something hitting obliquely. This one, the Riata Valley, is a series of impacts, but they didn't hit all at once. So it's just a bad luck for whoever was living there.
One of those aliens.
Now this is a picture where the color saturation has been cranked way up to show different mineral types. It's like most images are. It's probably a false color image. But the Riata Valley is down here, and this is Mar Nectaris, just above it. And this is illuminated probably about like this now. So there's a lot of good features here. There is a line of craters that goes right down this way. And that's usually something where there was a string of gravitationally influencing each other line of craters that all hit at once.
Hmm.
So let's see.
Is it pronounced Rieta or Rieta? Seems to be.
I think it's Reta.
Okay. That sounds.
Boy, you can't tell. Can't go to me for a pronunciation.
Yeah, yeah. Unless you've heard it by someone you know knows, you kind of come up with your own phonetics for some of these.
See, I got into astronomy when a friend of mine, Bill Skiles, and I were 11 years old, and we made flashcards of the constellations, and we learned the names of things, but it was just the two of us reading them, and we had never heard these things pronounced by anyone who knew anything. So I have some unique pronunciations of things.
And you also get a British version and an American version
yes.
for a lot of them.
What is that triplet? It's Theophilus and then Katerina on the bottom. What's the middle one? I can't.
Cyrillus.
Yeah,
Cyrillus. Yeah, that's one of the
Cyrillus.
Yeah, I forgot the name of that. That's one of the triplets. I always get Theophilus and the other one.
Katerina.
Yeah.
I got to tell you,
behind
gentlemen,
your head, Tim.
I got to tell you, gentlemen, between the moon and the planets and the NASA missions, I think they've cleaned out all the ancient Greek and Roman gods. There's just nothing available.
Just Jupiter's moons all by itself.
And Shakespeare is also pretty much used up.
Yeah, then in the 20th century, Russia got the first pictures of the Soviet Union got the first pictures of the backside of the moon. So there's a lot of Russian names around there. So this is a picture of Mare Nectaris taken obliquely from the Apollo 11 spacecraft.
Wow.
Out the window.
Wow.
God.
Look at the shadows.
Yes, very nice. The larger crater here is Theophilus, and Maedler is left, and the teardrop-shaped crater at the lower left is Torricelli.
Are we toward the north, where they might have water in the bottom of those craters?
No.
Okay.
This is stuff that's nearer the equator, so it gets a lot of direct sunlight down there. And the places where there's ice believed is in the South Pole.
Oh, not north.
No.
Uh-oh.
Now this is a drawing. This is not a photograph.
Well, it's not the moon.
No, but it's a representation.
Brown dwarf.
It's a representation, yes, of a brown dwarf.
Ooh.
Now, brown dwarf is like big Jupiters. Everything when it comes together is gravitationally attracted together, and it gravitationally continues to crush itself. So there's a lot of compression and friction buildup, and that builds up the heat inside these things. And things like Jupiter, for example, is also shines by its own heat from gravitational compression, but it's way out in the far infrared. It's not anything we notice visibly. Brown dwarfs are a little bigger. They're like 10 or 100 times Jupiter. They almost have enough mass to start fusion. They sometimes can start fusing deuterium, which is a pre-episode to starting hydrogen. They would have to start hydrogen and be able to continue it, and other elements too, but at least hydrogen in order to qualify as a star by definition. These are substars called failed stars. Nowadays in school, they give them a passing grade, but in my day, they give them a fail.
So this sucker is at the center of its own stellar system. It's not orbiting a star.
It is not orbiting a star.
It's the center. It's a failed star is what it is.
Yes, it is. But this one is looked at James Webb, and it has auroras around it. So it has a magnetic field, which is fine, but it also is getting ions from somewhere. And the analogy was drawn from Jupiter's moons, Io and stuff, that they emit ions into the space around Jupiter and cause auroras around, well, Jupiter has auroras too, but other moons have auroras. So they figure that this thing must have a moon also, because that's the most plausible scenario for auroras. The aurora is basically emission of methane. Methane, when it occurs, it's usually an absorption line, but here it's an emission line. So that's their evidence that it is aurora. They're not resolving it like you see here. They're just saying it's unusual to see the methane as an emission line, so it must be an aurora.
It looks like Jupiter through my CLS filter that I have.
But if this sucker is the center of its own system, why wouldn't that orbiting body be a planet?
It's got to be smaller than this object.
Oh, it's small. It's too small. It's a dwarf.
I mean, you could think of it that way, Ron. These things are all fuzzy definitions.
Yeah. There's no real sharp division between these objects. So the other one is in orbit around this, and it's in orbit close enough that it's being tidally disrupted to cause emission of something like water under the surface. So, but nature appears to make all these objects out of dust in the galaxy, and the smaller the object is, the more of it makes. So there are probably more brown dwarfs in our galaxy than there are stars.
Wow.
Typically, it's a power law, like Jerry said. If you're 10 times more massive, there are 10 times fewer of you.
Well,
Oh, I see.
Yeah.
Apparently all the dust and gas, all it congealed to was one brown dwarf and a moon, and didn't have enough to do a bunch of planets and a burning sun
Exactly.
in the middle.
Or it could be a planet and its moon, a big planet that got ejected from a solar system. You know, there's a wide scenario of ways this could have occurred.
And this thing could have multiple moons, but all we know is that there may be at least one.
Yeah.
And we've seen it. You can actually see it even though it doesn't shine?
No. They've just seen the emission from the auroras, and from that they infer that there may be a moon providing the ions.
How far
This
away?
drawing is misleading in that way. It implies that we see the object, resolve the object. We do not. It's a dot in the sky.
Since the James West can go out to 25 microns, could they be able to see the infrared radiation for this thing?
Yes, they do.
Okay.
Wow.
Yeah, this is probably just taken from a spectrum. You know, you're just looking at a graph that has emission and absorption lines on it. You're not resolving the planet into a disk at all, or this brown dwarf.
Yeah, this is what the artist thinks it looks like.
Yeah.
Okay. Now, in the last few days, we have had some exciting times from the sun. The solar wind, as you see, comes by the Earth. This is the Earth in here. And all these lines are the Earth's magnetic field, distorted by the stream of ionized particles, mostly protons and electrons that come from the sun as a plasma. Up here we get, this is the pole is up here. So this is up and down. This is the equator line along here. So this is where you would get some daytime auroras from here, source of nighttime auroras. That doesn't mean you see the aurora here. It means that the electrons that do it are following this line back to the Earth and coming in at the North Pole. And these ones here are following the lines, and they're coming in from the North Pole, but the sun side of the North Pole. And these are coming from the backside. See the E with the arrow pointing on it? These are captured and they follow the magnetic lines. A charge following a magnetic line looks like a spring. It wraps around very tightly as it spirals down. So that is a scenario of what happens here. Now it turns out that, let's see, I think it was Friday night that we had the coronal mass ejection passed by. The surge protectors on both my computers, which I had left the computers on, and I'm going, oh no. But the surge protectors were blown on both the computers.
Ooh. Ooh.
So I just reset them and everything's fine.
Wow, that's interesting.
We didn't get that here.
Mhm.
But it's
I
due to the
installed
recent-
the whole house surge protectors in my electric panels.
Were they blown or anything?
No.
Okay, mine were. So anyway, for this picture is from the San Juan Island from a friend of Mike Chibnick's, and Mike passed it on to us.
Actually, it's from my brother-in-law, Ron Nixon. He has a friend up there.
Okay,
And the
Sorry,
other one
it's
actually taken
Tim,
by
not. Okay. This one is from Montezuma Hill by Mike Chibnick
Mhm.
up near Rio Vista. And this one also.
So you're seeing the pink there, and that's high altitude oxygen. And the green that you saw in the first one from San Juan is lower altitude oxygen. And we don't see that here because we're farther south. So that's below our horizon from our point of view.
That's why
Yeah.
we couldn't figure that out. Mike couldn't figure it out. So that's very interesting.
and it's oxygen, that makes that colors.
Now,
Yeah.
this
We
one-
were at Denali National Park. You could see the auroras, and they were green.
Yeah.
Now, this is the lower oxygen, Chuck, the red.
No, the higher is the reddish, the lower is the greenish.
Okay.
So
Interesting.
this was taken from East Camino Cielo, and it was in our local paper here.
Huh.
And people were expecting to see this visually from Camino Cielo. And I don't know if anybody actually did because it would be really at low levels.
Yeah, and
But
faint.
it looks kind of like a whitish haze on the northern horizon with some vertical striations like you can see here in the red. And if you take a time photo or a high ISO photo with your camera, then you can see the color.
Chuck, you remember when we had some visitors from Canada once in a star party, and they were looking at our northern sky and saying, "We think that's an aurora there."
Yeah.
And it was verified later.
Yeah.
Well, is there a similar phenomenon going on around Australia, South Pole?
Sure. Yeah. My nephew lives in New Zealand, and he sent some pictures from his house.
Mhm.
But the reason it's spread out is super solar flares, prominences, something's going
Coronal
crazy.
mass ejections. Yeah.
Because they can always see when it's dark on the poles, they can always see them up in the,
Not always.
not
This
always.
is what it looked like from the South
There's the
Pole.
Australian one.
No, I'm talking about the fact that it's coming down into America now, as opposed to normally it's always up there,
That's great,
northern lights in the
Right.
Arctic Circle.
It's rare to see them at far southern latitudes. I think this last one made it down to Puerto Rico even.
Yeah, I heard that on somewhere on the news, I guess.
And
When
who
I was
around here
about
to
8
see
years
it?
old, I lived, my family lived in the San Francisco Bay Area, and we had an aurora, and it was pink. The whole sky was pink.
Hmm.
I saw one in 2001, I think it was 2000 or 2001. We were up at Kachuma Lake, and there had been a big coronal mass ejection. There was a huge sunspot, and it turned the whole sky to the north pink. And we also got some green blobs that were moving back and forth along the horizon, and some violet spikes that were going up from the horizon to the zenith and then disappearing. So it was pretty fantastic. And I went and woke up the campers around me, and one of the guys had been to Alaska, especially to see the aurora. And he said that this Kachuma display was better than he saw up in Alaska.
What do you suppose the ancients considered this or called it? The different religions.
Yeah.
God's
Bad stuff.
God's draperies.
Yeah.
No, they had to sacrifice a virgin to make it to appease the gods.
Strong impetus to not be a virgin.
Wow.
So this is the culprit. This is white light and hydrogen alpha of the sun. You can see some nice prominences down here. These were taken with a PST, very high quality for a PST, personal solar telescope. And this was taken with a Thousand Island or Thousand Oaks solar filter. So,
Well, is this similar to the thing that happened in the 1800s that killed the transmission lines of
the
telegraph?
Carrington event,
Yeah.
This was not as strong.
Not as bad. Okay.
This is a nice picture taken recently of the sun by the European Space Agency, showing the solar prominences above the sun's surface. And these define, you can see the magnetic field, which in this case, the magnetic field, it goes from sunspots to sunspots, and it goes up into the solar atmosphere, and the material is flowing down these lines back into the solar surface.
Wow.
Now, you once told me, Jerry, that it's not really positive and negative magnetic sunspots. It's not really.
Well, magnetism isn't plus or minus, it's north or south.
Okay, so it's a north and south, and does it flow from the south to north?
Well,
No, the loops are of plasma. They're an actual electrical current.
Yeah. And they've been lifted up. It's stuff that's been lifted up by the magnetic field, and then it just rains back down along the lines.
Right.
Spiraling as it goes.
And it doesn't go from like a positive to negative, or
well, the negative charges go toward the positive, and
yeah, it's not moving this way or this way. The material was lifted up all along here when this magnetic field line came up.
Oh,
it's like a Alfvén wave in plasma physics. It lifts the whole structure up, and then as it gets up here, it starts falling down, and it falls down in here, and it falls down there. And when it travels along a magnetic field line, it goes in very short spirals.
Okay.
The electrons, that's from the, what is it? The Lorentz force. Yes, thank you.
The microwave, in your microwave oven, there's a device called the magnetron, which makes the RF energy, and that uses the same thing.
Yeah.
Magnetic fields and the circulating electric.
Mm-hmm.
But do we get this effect only on planets with atmospheres?
You get this, you mean
in other words, let's say Mercury has no atmosphere.
The aurora, you mean? Yeah, you have to have an atmosphere to interact with. The particles come in on the planet's magnetic field, and as they they enter the atmosphere, they ionize or they excite the atmospheric atoms and molecules. If there's no atoms or molecules there, if it's like the moon does not have an aurora.
No.
But it does have proton bombardment all the time. So it's really nasty up there.
That's why the reflectance of the moon is only 16%, because it makes it dark. The photon bombardment.
Yeah, it ages it.
Yeah.
And this isn't an aurora here, Ron. This is plasma arcs on the sun. So this is a different thing.
Yeah, these are not auroras.
What's a prominence?
That's the stuff that's being held up.
Held up.
This is a prominence here.
Oh.
Things that stick up above the moon's or the sun's surface.
And which one of them are connected to the sunspots? Any of them?
Yeah.
All of them.
Yeah.
Oh,
they're associated with magnetic activity, and so are the sunspots.
There's always two sunspots.
Where it goes through the sun's surface, that's a sunspot.
And sunspots then occur in pairs because of that.
Yeah. So, for example, the magnetic field lines are coming out or going in through the surface right there. And then they go back through the surface the other way in one of these other spots.
And that's a really complex arrangement there. There's lots of plus and minuses, or north and souths going on in there. And that's why you get these coronal mass ejections. When they merge into each other and reconnect, you get a burst of energy that blows stuff off.
Well, they twist themselves off and they get pushed out.
Yeah.
And the PST image is lower left?
Yeah.
The bottom two are PSTs.
That's unbelievable. Must be double stacked or something.
Well, I think it's a stacked image, one through a Thousand Oaks filter that gives you the yellow-orange sun, and then the PST for the other stuff.
Okay.
You can kind of see a line there right on the limb.
Yeah.
Huh. Well, I've always thought magnetism was connected to metal. Is there a big metal core in the sun?
No, it's charged particles.
That's a whole, yeah.
In the
Those
planet,
a whole-
particles
that's a
create
whole lecture
magnetic
by
field and
itself.
vice versa.
but the planets have to have a metal core.
No, they just have to have electrical fields going on, electrical activity, a dynamo of some kind. Now that's easier to do with a metal core.
Is it?
But like on Jupiter, you have metallic hydrogen. You know, we wouldn't think of that as a metal core here.
But we have the loops of plasma, not plasma, of molten metal in the Earth. So that's a plasma, and that's moving charge that creates a magnetic field.
Well, that's pretty much what I was asking about.
Yeah.
Thank you, Bruce.
Okay.
Aha, is this Tess?
This is a minute and 46 seconds.
All right, turn it up.
Black hole destroy a star. This was a tidal disruption event, which occurs when a star passes too close to a black hole. Extreme gravity break apart into a stream of gas. The tail of the stream escapes into space, but the rest swings around to form an accretion disk. This event, called Assassin 19BT for the All-Sky Automated Survey for Supernovae,
orbit of
which
Mars.
first identified it, happened at the Hess Continuous Viewing Zone. Hess's 4 cameras scanned large sectors of the sky, and one constantly monitored this region for a full year. Hess saw Assassin 19BT as soon as it started to brighten, days before other observatories spotted it. NASA's Swift satellite quickly observed the outburst in visible light, UV, and, along with the European XMM Newton satellite, X-rays. The UV measurements are the earliest recorded for a tidal disruption to date. They showed the event's temperature dropped almost 50% in just a few days. Such a steep decrease has never been seen in a tidal disruption before. These outbursts are rare, happening only once every 10,000 to 100,000 years in a galaxy like our own. Future discoveries will help us learn even more about these uncommon cosmic blasts.
Okay. Oh, how do I get out of this?
Escape.
Yeah, I thought of
How
it
we get
just before you said it there.
That's how we get accretion disk.
So let me go.
A great video.
Yeah, so that sets the stage for, let's see, get back to the,
Hess is a telescope, right?
yes.
It's not a
It's an
radio.
exoplanet searching scope, but it finds other things too.
Okay, but it's not sitting out there at one of the Lagrange points like Webb.
I'm not sure what kind of orbit it's in.
Wouldn't be geosynchronous, would it? Do we have them stuck out 23,000 miles? So they're just
Probably not. No.
Can you see this share?
We're seeing your file list.
Oh, okay. There.
There you go.
Yep.
Okay.
Ooh.
Now, what you just saw was a video of a black hole where a star had come too close to it and was absorbed, torn apart, and then part of it was entered the black hole, part of it formed an accretion disk, and a lot of it was flung out into space. Now, this is what happens. This is the core of the Andromeda galaxy where there's a supermassive black hole, not just a black hole. And the study here is showing the path on a galactic scale of what's called a small but steady flow of food into the black hole. Both the Andromeda galaxy and the Milky Way have massive, supermassive black holes about the same size, but they don't have an event like that. These are dust clouds and that are being sort of steadily absorbed by them. So no big event there. But some galaxies do have a supermassive black hole, And every now and then you get a major big event like that where some gas giant got too close. But right now we don't have any. We have a sort of a steady state quiescent black hole.
I thought
Jerry,
the
this may be a topic for some other time, but can they measure these masses of the black holes when they say supermassive? Do they do that by the size of the galaxy and the speed at the?
No, anytime you have two objects that you can see rotating around a common center, the math allows you to determine the mass of each object.
Oh, okay.
You can just calculate the mass. These, and you know, the core of the Milky Way has this supermassive black hole, and they have now about a 15 or 20-year movie they made of stars moving around that. So
Wow.
they're able to very accurately determine the masses of these things from the math for the orbits.
Wow.
And for stuff really far away, there's sort of an ad hoc relationship between the size of the bulge of the galaxy and the size of the black hole, the supermassive black hole. So there's some rules of thumb that are used based on what we observe nearby.
Oh, okay. So the bulge says a little something.
Yeah.
Yeah.
Okay.
But your supermassive is the center of every galaxy. They don't have other supermassives. They're different categories.
Some of them do. I think Andromeda has two supermassive black holes.
It's almost like having two centers.
Yeah, well, two galaxies merged to form the current one.
And they're still in process of merging.
Oh, and sooner or later, those supermassives will maybe come together and become a really super duper massive.
And then
Yep.
we'll pick them up on the LIGO detector.
Yeah.
Maybe they're a belly button.
Yeah.
Supposedly there's three classes, right? There's 3-4 times the solar mass. Those are relatively small baby black
Small,
holes.
medium, and large.
Small, medium, and large. Well, heaven forbid one decide to come through the solar system. I think we'd be in deep caca.
Okay, we're going to do another short video.
Okay.
Aha. This one we didn't see.
This is 4 minutes. We have time.
Crank it up. Ah, I remember this headline. We're going inside, gang. Brace yourself. It's a Disney
Now,
ride.
this is a supercomputer. No camera actually did this. This is a supercomputer simulation.
Wow.
With no narration.
My black cat likes the black hole noises.
Whoa. Good Lord. That's good LSD, man.
Huh.
Hmm.
You're inside now.
Yeah, like we'd survive that.
Depends on the size of the black hole. Actually, you're more likely to survive with a supermassive than with a small one.
Yeah.
I used to have nightmares as a kid of landing on a planet the size of Jupiter and suddenly weighing 4,000 pounds.
Now over here on the right, you can see the camera, its position, and the black hole is the circle. The orange lines are the ring around it.
Hmm.
See, it's passing through the ring now. You can see the camera. And then it's heading toward the event horizon. Or it's at the event horizon. Now it's inside.
I remember reading the inside of a black hole might be actually quite bright from all the stars that are in there.
So the event horizon is a shell. The singularity is the dot in the middle where we all end up, but we never make it past the shell, do we? As far as that's when time stops.
Oh, it's a mess. Time and space both kind of stop. So
You remember the first
If
remember
you
the
look, if you are looking from the Earth through a telescope and you're watching that spaceship or camera as it approaches the black hole, what you will see is, because of the gravity of the black hole, you'll see the camera speed up as it's attracted to the black hole. And then as it gets closer, you'll notice it slows way down. And from our position outside the black hole, it would slow way, way down and never actually reach the black hole's event horizon. But if you were at the camera holding it, you would just cruise through at your normal speed. You wouldn't notice anything different. You just, it's not, there's nothing there. It's like Oakland. There's no there.
well, there's an effect called spaghettification, if you recall. That might
that happens when you've got a gradient, a strong gradient, and that happens more often around a small black hole than a big one, because you're getting closer to the very center than you are with a supermassive one.
Wasn't there a theory somewhere that said that we're actually in a black hole now?
Yeah.
There's a lot of speculation about that. I wouldn't take it too seriously.
Yeah,
I wouldn't call it a theory quite.
Yeah.
But now every body, including the Earth,
before the Big Bang, there was no up, there was no down, there was no side to side.
There was no up, there was no down, there was no side to side. There was no light, there was no dark, nor shape of any kind. There were no stars or planet Mars or protons to collide.
Sorry, it's getting away from me.
Before the Big Bang, there was no up, there was no down, there was no side to side.
There was no up, there was no down, there was no side to side. There was no light, there was no dark, nor shape of any kind. There were no stars or planet Mars or protons to collide. There was no up, there was no down, there was no side to side. And furthermore, to underscore this total lacking state, there was no here, there was no there, because there was no space. And in this endless void, which can't be thought of as a place, there was no time, and so no passing minutes, hours, days. Of all the paradoxes that belabor common sense, I think this one's the greatest, this time before events. Because how did we get from nothing to infinitely dense, from immeasurably small to inconceivably immense? But before we get unmoored from the question at the start, let's take a breath and marvel at when math becomes an art. Because we don't have to understand it to know there was a time when there was no up, there was no down, there was no side to side.
Before the Big Bang, there was no up, there was no down, there was no side to side.
So that one didn't have a stop button, so I apologize for that.
Well, there's still no up or down if you're out in space.
Yeah, well, no, you get to define them, but there is space.
Yeah, and there wasn't any space. There was no medium.
That's right. Pre-Big Bang, no nothing.
Space time was good. So the
Well,
nothing.
on the space station, there is no up or down either.
No, you get to pick it.
Yeah, it's wherever you want.
Okay. So this is the poem. It's called Before the Big Bang. There was no up, there was no down, there was no side to side. I don't know who originated it. It seems to be a few years old, but it's quite beautiful and it discusses the problem of what was there before time. And all these things are mind-bending about it. But the key phrase is, let's take a breath and marvel at when math becomes an art. So we can describe the universe now in terms that we like, of mathematical terms. And those mathematical terms give us statement about what was before. You know, what is south of the South Pole? That's a concept our minds don't readily image. And so you get it from the math. And she says you don't have to, because we don't have to understand it, but we know there was a time. There was something before the universe began, possibly. Now, there are theories and speculations that the universe is infinite in duration and always has been and always will be.
Well, that would be steady state.
No, it's not steady. That was a steady state theory that has been pretty much debunked. That was due to, oh, I forget.
Oil.
Oil,
Yeah.
money, and gold.
And the idea was that the universe was always expanding, but as it expanded, it stretched space-time, and virtual particles were then created in the stretched space-time to always make up for what was moving away. So the density always stayed the same. And that's not true. But a good idea.
But the universe could be cyclic. You could have big bangs and Gnab Gibbs, big bangs backwards with crunches. If things that we think are constant aren't really constant.
Well, there's also theories that there's an ultimate or a unlimited number of universes, multiverses, bubbles everywhere. We're just in one of them.
Yep.
That's a speculation too, yes.
I wouldn't put it
No
past
evidence for any of that yet. People are looking at the Big Bang's what's that, microwave background.
Oh, yeah.
For features that are not statistically random. They're looking for signatures of previous universes.
Or where we bump up against another bubble.
Yeah.
Huh.
But did any of you hook into Bob Berman's theory at the end of his talk that he made from his home and back in March, where he said the universe is conscious? It's like a big god.
That's not only
woo.
that's a big speculation. That's a big leap.
Well, one scientist says that he saw a galaxy that was doing something on purpose that it shouldn't be able to do.
I haven't heard that. If you look on the internet, I would say that significantly more than half of what you read about science and the universe is just craziness.
Yeah.
One guy made some claim and I wrote back and I said, well, there's a lot of arm waving going on here, but I don't see any real explanation. And he said, well, this is so obvious it doesn't need an explanation.
But I know you
There's
guys have,
other ones where they come on with a bunch of hoopla, blah blah blah, blah blah blah, and you go through the whole thing, and it's just simply a lead in or a lead up to nothing.
Or it's a product that someone's thought of.
Yeah.
I know that each and every one of you guys has your own deep down theory about or feelings about how many life sections are out there, how much intelligent life. I have a feeling it's everywhere, but we'll never be able to communicate with it. We're just too damn far apart.
Yeah. Until we learn how to travel faster than the speed of light.
Yeah, but happened here.
I used to be a active rock climber and mountain climber. And there was a famous thing where people would say, well, this will never be climbed. And now teenage girls with tennis shoes go up for a day hike on that thing. So there's a danger to saying never.
Yeah.
Never say never.
Never say never.
Yeah.
It sounds like a movie.
Yeah.
I like the one where it says 87.7% of all statistics are made up.
On the spot, yeah.
Can you make that larger where we can read it? Again, I wrote it down. Before the Big Bang, there was no up, there was no down, there was no side to side. Okay.
Yeah. Can you see this okay?
Yeah.
Yeah, that's nice.
Yeah, it's back in our email boxes.
Yeah.
Big Bang poem.
Yeah, I have the Word document open on my big computer, and I can,
Yeah.
I have no problem seeing it at all.
If you try and say it real fast, it takes some practice. It's
Got to get the meter down.
But that lady does it really well.
But you never heard it once on the Big Bang Theory TV show, did you? Those guys.
No.
Gentlemen, did we cover it all? Do we want to talk about some outreach stuff going on, Mr.
Sure, you go ahead.
Well, just, weather permitting, Telescope Tuesday, Montessori Center School, Science Night, and then Westmont, third Friday of every month. And then Saturday is International Astronomy Day.
Let's hope that the clouds have gone.
Yeah. Yeah, normally I have 5 weather sites that I kind of look at them all and take a vote. But when you're dealing with marine layer like this, it turns out that some of the astronomy sites that are normally more accurate get less accurate, and the pessimistic sites like the National Weather Service get a little more accurate. They're a little better at predicting the marine layer.
Yes, yes.
I use the method of looking out the window.
Yeah. But that, people are asking me days ahead, are we going to do it? Are we going to do it? And it's like, I don't know.
Wait and see.
But International Astronomy Day is celebrated everywhere.
Yeah.
Okay, but our museum goes where we go, out to a shopping center in Goleta, right?
Right. That's because the museum has a very restrictive conditional use permit.
Oh,
And the neighbors complain.
okay, but we're going to be out there 10 to 10. 10 a.m. is in the morning.
Yeah.
It's a break
And-
for dinner.
Okay, and how many scopes? How many guys have you signed up? A lot of them.
Have no idea.
Yeah.
What
Are
do you
you
call a deer with no eyes?
Yeah.
I will bring my solar scope, my H alpha.
Okay, good.
So back in the 70s, they on Saturday Night Live, they had a weather report with John Belushi and Freud.
Yeah.
And they said, and now for the weather, stick your head out the window. If it comes
Yeah.
out wet, raining.
Yeah, this is not one of the great seeing spots in America, I would imagine, is it?
Well, it's not bad.
Yeah, we have actually one of the best places, surprisingly enough, was out at the Bacara.
Yeah.
On certain occasions, the air was so steady, I'd get, with my 5-inch refractor, I'd get just stunning, steady views of the planets.
And we got that a lot at Refugio State Beach.
Refugio, yeah, that's going to mention that
Oh,
too.
that's another thing outreach wise. Refugio is closed because of the damage they got from high tides and rain. And so the June events that we're going to have scheduled that would normally be at Refugio, we're going to be doing at El Capitan State Beach.
But there you got too many trees.
Well, not in their day use parking lot. It's pretty open. So it'll be right on the beach, similar to Bacara, but of course not 30 feet above the ocean.
I used to ride an airplane with a guy over the hill, and the fog and smog and gray would end at the mountaintop, and you could see beautifully inside the valley over there. So that leads me to think Kachuma.
Yeah.
Well, I was just going to, yeah, we see that very often at Kachuma. As soon as you come over the 154, over the peak, over the ridge, all of a sudden you're in fog. But it was really good seeing when we were at Kachuma.
And Kachuma, there's some complications this year. Apparently, there's a new director and there's a new naturalist that's our contact point. And I haven't met or heard from this person yet. But we arranged with Rosie, the previous naturalist, to have 6 or 7 events in July and August, and then to have our camp out. So the camp out is set. And we'll see what happens, assuming that they, that it all holds true.
And that would be Diane Wilson back handling part of that too, our new events lady.
No, she would be handling the food for the camp out.
Oh, just the food part. Okay. Wow. Well, we do meet regularly, do we not, at Camino Real for something else? And I'm confused now. It's not International Day.
It's Telescope Tuesday.
Oh, it's Telescope Tuesday. But there's also a Sunday morning or a Saturday morning or some weekend thing that occasionally happens out there, isn't there?
Well, International Astronomy Day and the eclipses.
The eclipse. I guess that's what I'm thinking about.
Yeah.
Okay.
No special events.
What's the date of our camp out?
Oh, October something.
Way out there. Okay.
Last weekend in October. Just a second. I can't reach my calendar, but Pat just got it for me. And it is October 25th through 27th.
Well, I want to thank Mr. Whittemore for, I think he's going to run a little piece in the newsletter for June about our newly acquired Midwest farm boy that turned into a great astronomy programs manager, and he's going to give us our talk. Because I got to tell you, nobody was available. I had calls out to everybody, and everybody's heading out on vacation, summer holiday. But John's got a great program that most of us missed when he did it down at Dargan several months ago. And I guess it's on moons in the solar system, certain moons that are incredible. That'll be on the 14th of June, ladies and gentlemen.
Right. Flag
Second
Day.
Friday,
Flag-
yeah.
Flag Day, Ron.
Is
Flag
that
Day.
Flag Day? Okay.
Yes,
And then
14
a week
June.
before the 8th of June, which is actually the second Saturday still, is when we'll have Star Party, right?
Yeah.
In June. And then in July, we meet and eat. Gather together. On that note, gentlemen, thank you. That's going to do it. SBAU Astro Hour number 168. And we'll have number 169 next week for May 20th through the 26th. Come join us this Saturday at Camino Real Marketplace. And come out there tomorrow night and see Jerry and myself. I'm going to drive out and see you. We'll see you guys on the screen next Monday morning.